Hello my dear wonderful genius students, I'm back again with a new video. This is lecture number 15 on complex analysis and it is the continuation of the last video. Students, in my last video I was explaining the complex integration and in that video I solved two numerical problems. In this video also I am going to solve more numerical problems to understand this topic more clearly. So without wasting time, let's get started. Problem number 1. Evaluate the value of the integral this one along the straight line joining 1 minus iota and 2 plus iota. Students, let us find out the equation of the straight line joining these 2 points. The equation of the straight line joining the points 1 comma minus 1 and 2 comma 1 is given by y minus y1 is equal to y2 minus y1 divided by x2 minus x1 into x minus x1. In our case, x1 is 1, y1 is minus 1, x2 is 2 and y2 is 1. So, substituting these values in this equation, we will get y minus y1. So, in our case, y1 is minus 1. So, minus minus plus y plus 1 is equal to y2 minus y1. y2 is 1, y1 is minus 1. So, minus minus plus divided by x2 minus x1. x2 is 2 and x1 is 1 into x minus x1. So, in our case, x1 is 1. Now, let us simplify this part. Y plus 1 is equal to 1 plus 1, 2, 2 minus 1, 1. So, 2 divided by 1, 2. So, twice x minus 2. After simplifying, we will get y is equal to twice x minus 3. So, therefore, dy is equal to 2 into dx. Students, next our target is to express this part either in terms of x or in terms of y only. For simplicity, I am going to express this part in terms of x only. Therefore, integration 1 minus iota to 2 plus iota twice x plus iota y plus 1 into dz is equal to integration twice x plus iota y. In our case, y is twice x minus 3. So, iota into twice x minus 3 plus 1 into dz. We know dz equal to dx plus iota dy. Since in our case dy equal to twice dx, so dz will be equal to dx plus iota into twice dx. So, dx plus iota into 2 dx. Since everything is written in terms of x only, so we have to change the limit from 1 to 2 because x1 is 1 and x2 is 2. So, lower limit is 1 and upper limit is 2. Now, let us rearrange these terms. Integration 1 to 2 twice x plus 1 plus iota twice x minus 3. Now, let us take dx common from this term. So, finally, we will get 1 plus twice iota into dx. Finally, we can write 1 plus twice iota into integration 1 to 2 twice x plus 1 into dx plus iota integration 1 to 2 twice x minus 3 into dx. Next, 1 plus twice iota. After integrating this part, we will get x square plus x, limit is from 1 to 2, plus iota. Again, let us integrate this term. After integrating, we will get x square minus 3x, limit is from 1 to 2. So, after putting these limits, we will get 1 plus twice iota into 2 square plus 2 minus 1 square plus 1 plus iota 2 square minus 3 into 2 6 minus 1 square minus 3. So, after simplifying this part, we will get integration 1 minus iota to 2 plus iota twice x plus iota y plus 1 into dz is equal to 1 plus twice iota into 4 plus iota into 0. So, after simplifying, we will get 4 plus 8 iota, which is the answer. Now, let us solve the second problem, and according to this problem, we have to evaluate this integral where c is the straight line joining from z equal to minus iota to z equal to plus iota. Students, again we have to find out the equation of the straight line joining these 2 points. The first point z equal to minus iota will be located at this location and z equal to plus iota will be located at this location, and the equation of the straight line joining these 2 points A and B will be equal to x equal to 0. The equation of the straight line, joining the points A 0 comma minus 1 and B 0 comma 1 is given by x equal to 0. So, therefore, dx will be equal to 0. Now, integration along part C, modulus of z dz will be equal to integration. We know z equal to x plus iota y. Since in our case x equal to 0, so z will be equal to iota y. So, therefore, dz will be equal to iota dy and modulus of z will be equal to y. Let us substitute the values of modulus of z and dz in this equation. So, we will get modulus of z y and dz will be equal to iota dy. Since everything is written in terms of y only, so the limits will be from minus 1 to plus 1, because in our case y1 is minus 1 and y2 is plus 1. So, lower limit will be minus 1 and upper limit will be plus 1. So, this part can be written as iota into integration minus 1 to plus 1 y dy. Now, let us split this integral into two parts. So therefore, integration along part C modulus of z dz will be equal to iota integration -1 to 0. For -1 to 0, the y value is -y. So minus y dy plus iota integration 0 to 1. For y equal to 0 to y equal to 1, the value of y is always positive. So y dy. Now let us simplify this term and this term. So iota minus y square by 2. The limits will be from -1 to 0 plus y square by 2 limit will be from 0 to 1. So after putting the limits, we will get minus iota into 1 by 2 plus iota into 1 by 2. So after simplifying, we will get iota, which is the answer. Next, let us solve the third problem, and according to this problem, we have to evaluate this integral where c is the left half circle modulus of z equal to 1 from z equal to minus iota to z equal to plus iota. Students, before solving this problem, I want to mention a very important concept, and that concept is general equation of a circle. Students, the general equation of a circle is given by modulus of z minus z naught equal to r, where center of the circle is given by z naught and radius of the circle is r. In our problem, the given circle is modulus of z equal to 1. That means the radius of this left half circle is 1 and the center of this circle is z naught, that means at origin. So let us solve this problem. So integration along part C modulus of z dz is equal to integration. In our case, modulus of z equal to 1. So 1 dz. We know in exponential form z is given by r into e to the power iota theta. Since in our case r equal to 1, so therefore z will be equal to e to the power iota theta. So therefore dz will be equal to iota into e to the power iota theta d theta. So dz will be equal to iota into e to the power iota theta d theta. Now let us find out the limits. Students, the point z equal to minus iota correspond to theta equal to 3 pi by 2. Again, the point z equal to iota corresponds to theta equal to pi by 2. So therefore, the limits will be from 3 pi by 2 to pi by 2. So lower limit will be 3 pi by 2 and the upper limit will be pi by 2. Now let us simplify this integral. So iota into integration 3 pi by 2 to pi by 2 e to the power iota theta d theta. Iota, after integrating, we will get e to the power iota theta divided by iota, limits will be from 3 pi by 2 to pi by 2. So therefore, integration along part C modulus of z dz is equal to e to the power iota theta. Limit is from 3 pi by 2 to pi by 2. Now let us put the limits. So after putting the limits, we will get e to the power iota pi by 2 minus e to the power iota 3 pi by 2. Now apply de Moivre's theorem. So e to the power iota pi by 2 can be written as cos pi by 2 plus iota sin pi by 2. Again, e to the power iota 3 pi by 2 can be written as cos 3 pi by 2 plus iota sin 3 pi by 2. We know cos pi by 2 value is 0 plus iota. Sin pi by 2 value is 1 minus cos 3 pi by 2 value is 0 plus iota. Sin 3 pi by 2 value is minus 1. So, after simplifying, we will get twice iota, which is the answer. So, this is all about today's video, and I hope that you have learned a lot from this video. In my next video, I will be teaching you Cauchy's integral theorem.